Part of the lecture, we're going to go over naming. And specifically, we're going to go over metallic naming. With a lot of this, it's just going to come with practice and memorization. There's just rules that you need to memorize. And there's really no other way around it. So I'm going to kind of go over those rules, give some examples, and hopefully it'll make it a little easier. And I'll show you a website where you can get some extra practice done if you want, in addition to your homework. Okay. So let me go to the next slide here. Come on. There we go. So the first type of naming we're going to look at is main group naming. And if I actually pull up over here, let me show you the periodic table. So main group, if you remember from chapter 2, this is going to be these groups here. So group 1, 2, then 3 through 8. So not transition metals. We'll do transition metals, but not at this very moment in time. So right now we're going to be looking at mainly groups 1, 2, and 3, because we're going to be looking at metals. Okay, so let me pull this to the side here. Pull up the PowerPoint. Okay, so how you name these, if you follow my little guide right here, you name the cation, which is the metal, and then your base name plus ide, your anion plus ide. So let's look at this. So for example, NaCl. So the name of the cation is the first element listed, which is sodium. Na is sodium. And then we're going to have the base name of the anion, so it's chlorine is the name of the anion, plus ide, so it would actually be chloride. So this is sodium chloride. So let's look at the next one, KBr. I'll write this over here. Where are you? Here you are. K, and you can't see that. Let me try this one. Okay, that is strange. Okay, let me color this whole in white. Okay. K B R. Okay. So this right here, K is potassium. Okay, so that is just potassium. M. Okay, and then Br is bromine, but we don't name it bromine, we name it bromide. So potassium bromide. Okay, and the next example we had over there was Li2O. Okay, so we don't do anything with these twos or anything. Okay, not with main group. We just remember name the metal, which is lithium. Okay, and then this is oxygen, but we don't name it oxygen, we name it oxide. Okay, so remember with main group metals, okay, we name the metal, and then the anion plus ide. So potassium bromide, lithium oxide. Let's do another one. Let's do MgCl2. Okay, that'd be magnesium and then Cl is chloride. So magnesium chloride. And again, with main group metals, we don't do anything with the subscripts. Okay, now let's see how to write these from the formulas. So that's how you name them. Okay, so now let's write them. So let's say I have, let's do MgCl2. Or no, I'm sorry, let's give the name. So magnesium chloride. Okay, how do I know how to write the formula? And what you do is you write down the element. So I'm just going to put Mg, and then chlorine would be Cl. And then you put their charges they would have. Okay, so let me pull up the periodic table again. Oops. Okay, so chlorine right here is group 7, so that would have a -1 charge, and magnesium in group 2 right here, so that would have a 2+ charge. So let me pull this down and write this on here. Magnesium 2+, -1. Now all you do is you cross these numbers down. So this number will go here, and this number will go here. So that'd be MgCl2. See, the 2 went to chlorine, the 1 went to magnesium. And this is just to neutralize them. So let's look at this. Magnesium has a 2+ charge. Okay? But chlorine has a -1. Now right now, 2+ and a -1, that would still equal to a +1, right? So I need to neutralize one more positive charge, so we need 2 chlorines. So let's look at this. I have a magnesium with a 2+. Now I have 2 chlorines with a -1. So when I add those together, that will equal to 0. So it took 2 chlorines to neutralize 1 magnesium. So that's why we have MgCl2. And the shortcut is just to cross those numbers down. So let's look at another one. Let's look at lithium oxide. Lithium oxide. So we have lithium and we have an oxygen. Pull up the periodic table here. Lithium is in group 1, so it has a +1 charge, and oxygen is in group 6, so it's a 2- charge. So we have +1 -2. Okay, so we have oxygen has a 2- charge, lithium has a +1 charge. Okay, so which number is higher? Oxygen. So that means it's going to take more lithium. How many lithiums do we need? 2, right? We need 2 charges to neutralize this 2 charge. So again, the shortcut would be crossing it down. So the 1 will go right here, the 2 will go right here. So it's going to take 2 lithiums to neutralize 1 oxygen because the lithium has a +1 charge. Let's look at aluminum oxide. Aluminum oxide. Okay, aluminum is Al and oxygen is O. Now we've already looked up oxygen. We said it has a -2 charge from above. It still does. Okay, now let's look what group aluminum is. Aluminum, right here, here's aluminum, is in group 3, so that would be a 3+ charge. oops, let's make that a 3. That is a ugly 3. Plus. Okay, so if we cross the numbers down, we'll move the 3 to the oxygen and 2 to the aluminum. Okay, so aluminum now has a 2 and oxygen is a 3, and that is how you write aluminum oxide. Can we do one more example? Let me clear this. Let me see if this could be a shortcut. Never mind, I don't know where my box went. So File, New, don't save. Okay, let's look at calcium oxide. Okay, now let's write calcium oxide. We've done oxygen a few times now. Oxygen has a 2 minus charge, or you say minus 2 if you want. Now let's look at calcium here. Periodic table, here it is. It has a 2 plus charge right here because it's in group 2. Again, just so remember, everything in group 1 has a plus 1, group 2 has a plus 2, group 3 has a plus 3, and if we go backwards, fluorine is a negative 1, oxygen negative 2, nitrogen negative 3. So just remember that, that's from chapter 2. So calcium has a 2 plus. Okay, so if we cross these down, we would have a 2 right there and a 2 right there, so we'd have Ca2O2. Now here's just kind of like one more rule. This is why I wanted to use this example. Do you see you have a 2-to-2 ratio? It takes two calciums to neutralize 2 oxygens. Or another way of saying that is 1-to-1. So calcium oxide, 2-to-2 or 1-to-1. So it reduces. So anytime you can reduce it, you can. So let's say hypothetically, this isn't true, but let's say we got Ca2O4. Well, do you see how these both can be divided by 2? Well, then it would have become CaO2. Or in this case, 2-to-2 becomes 1-to-1 because they both can be divided by 2. So it's always going to be your lowest common denominator. So main group metals, again, you're going to put your charges and then you cross them down, and then make sure you can't divide them by a lower number. And then when you name them, you just put the metal plus your anion ending in "ide." Now let's look at polyatomic with these. And I'm skipping a little bit ahead in the PowerPoint because I think it would be easier this way. Polyatomic are going to be named the same way. Here's polyatomic. So you're still going to have your metal, your main group metal, but then you're going to have the polyatomic ions here. These will need to be memorized. You need to memorize not only the name of them, but also the charges of them and what they are. Okay, so if I said sulfate, you would have to know that is SO4 2 minus. Okay, but if I put down SO4 2 minus, you need to know that it's sulfate. So you need to know these backwards and forwards. Do you see most of them have a -1 charge, but occasionally you'll get, like a -2 charge or something. And the -2 charges are with your sulfs, if you want, sulfate, sulfite. The other trend that you're going to see is with the oxygens. So the oxygens go, if I write these down for you, with the least amount of oxygen, you have your ites. It goes ite, or actually let's go hypoite, hypo name ite. you have ite, then you have ate, and then per name 8. So let's see what I'm talking about here. So a good example would be the chlorides. Okay, so there is ClO minus, ClO2 with a minus, ClO3 with a minus, ClO4 with a minus. Okay? This is called hypochlorite. Add another oxygen, and it's called chlorite. Add another oxygen, and this is called chlorate. And add another oxygen, and it's called perchlorate. So if you look on here, those are all on here. Here is hypochlorite, and then chlorite, and then chlorate, and then perchlorate. Anyway, that's just a trend with oxygens. You'll see the ites and the ates. So here's sulfite. Add another oxygen, you become sulfate. Anyway, that's just a trend. It might help you memorize them, maybe not. Anyway, so just start becoming very familiar with these. So all you're going to do is write the metal plus the polyatomic name, okay, when we're naming them. So let's look at an example here. Let me see. Here's one. Okay, so what if we have, so again, the rules are the same, except now you have, a special polyatomic K2SO4. Okay? What is the name of this? Okay, just like we did before, we're going to name this part here, the metal, which is potassium. Okay, now we need to name this whole entire anion here, this polyatomic. Polyatomic, poly meaning many, and atomic meaning atoms. So you have many atoms right here, so more than one. And we're going to look up SO4, and we'll look up it's right here, and that is called sulfate. So this becomes potassium sulfate. Okay, so not hard. So instead of just being like potassium, if it was K2S, that would be potassium sulfide. How do I know when to do sulfide versus sulfate? Well, look here. Sulfur, there's just one atom, right? There's your metal, potassium, and then one other atom. So that would be your ide rule. But do you see here I have potassium, but it's bonded to several atoms right here. SO4. Remember, see, that's not just one type of atom, it's two types of atoms. So that's your polyatomic. So now we're going to name it potassium sulfate. Sulfate because that's what it says on the chart. If I come here, SO4 sulfate. I could have, if it was this, so let's say I had K, 2, SO3. Okay, again, this is potassium. Okay, but SO3 isn't sulfate. Let's look it up. SO3 is sulfite. So I come back here, it'd be potassium sulfite. Let's do another one. Let me think. Let me put magnesium. I don't know. Nitrate. Okay, so let's do Mg NO3 2. Okay, so we recognize our metal as magnesium. So this would be magnesium. Okay, so now we need to see, is it the Ide rule or is it a polyatomic? We'll look in parentheses here. Is there more than one type of atom? Yes. So we go to our polyatomic chart, go to NO3. NO3 is called nitrate. So that's what we write down here, magnesium nitrate. Okay, so those are the rules. So on both ways, you're going to name your metal, whatever it is. And then you look at what it's bonded to. Is it bonded to one atom? So it'd be like sulfide or oxide or fluoride. Or is it bonded to a polyatomic atom like these? And that's where you have to go back to your chart. Now let's see if we can go backwards. So if I give you the name, can you give me the formula? Okay, so let's start all over. And this is with your polyatomic. So let's see here. Let me find one. So if I give you, let's just go back. Let's go potassium, sulfate. Okay, we know the charge of potassium from the periodic table. Potassium is right here, K. It's a +1. And sulfate, from our polyatomic chart, is right here with a 2- charge. That's what it says on there. Okay? So just like our rules before, we're going to write potassium with a +1 and sulfate, SO4, with a 2-. Okay? So look here, let's look at the charges. Do you see that it's going to take 2 potassiums to neutralize 1 sulfate? Because this has a 2- charge. When these add up together, they need to be 0. Or, another way of looking at it is crossing the charges down. So 2 potassium for 1 sulfate. So this ends up being K2SO4. All right, let's look at another one. We looked at, okay, let's look at sodium, nitrite. Okay, sodium is Na. And it's in group 1 right here. Okay, so that is a +1. And let's look at nitrate. Nitrite right there is NO2 with a minus charge. So let's look at NO2 with a -1. Okay? Do you see that these are already neutralized? A +1 and -1 will equal to 0. So we just write NaNO2. Let's do one more example. Let's do lithium dichromate. Okay? Lithium dichromate. So lithium is right here, group 1, so it'll be a +1 charge. So we're going to write over here lithium with a +1, and then dichromate, let's look up on here. Dichromate, Cr2O7 with a 2- charge. So Cr2O7 Cr2O7 2 minus. So we're looking at all of this together, okay? Did you see that it's going to take 2 lithium to neutralize 1 dichromate, because this has a 2 minus charge. So you cross the charges down if you want. It takes 1 of those, 2 of those, so lithium 2, and then dichromate O. Oops, that's a 7, not a 2. 7. This is all together here. Okay, so hopefully that helps you with the main group elements. Okay, so remember, all you do, your metal, and then if it's not a polyatomic, then it ends in I. And if it's polyatomic, just write down the name of the polyatomic. Now when you're writing the formula, remember all you do is you write the charges at the top and then cross those down. And remember to have the lowest denominator. Alright, so the next lecture what we're going to do is go over transition metals. So that would be these right in here. These metals don't have set charges. You know, like main group metals, this is always a +1, this is always a +2, this is a 3, -1, -2, -3. Okay? But what happens when we don't have a set charge here? Where I never went over charges because a lot of these can hold different charges. It can pretty much hold whatever charge it wants. Now it has common charges, but it really can hold a lot of different charges. So how do we determine what the charge is? So we'll look at that next.